We will solve problem 31, chapter 6 of HC Verma. In this problem, we have two masses, one kept on the other, and the combination is placed on a rough surface. The frictional coefficient between the this is mu, and the frictional coefficient between the m1 and m2 is mu upon 2. Now let me separate them and have a free body diagram. If we see it like this is how they are in touch, and it is placed, this is m1 is placed on m2. At initial moment both are given velocity v0, so both are given the velocity v0 at t is equal to 0. This is v0 and this velocity is v0 in absolute frame. If I look in this frame, the velocity of m1 vi is 0 at t is equal to 0 in the frame of the bigger mass, and the smaller mass will fall when it travels L distance in the frame of the bigger mass, and the initial velocity of smaller mass is 0 in the frame of the bigger mass, because both are traveling with the velocity v0. So the relative velocity of m1 in this frame is v0 minus v0, which is 0, because I'll be solving this problem using the concept of frame, moving m1 in the frame of m2. Now let us see what all forces are acting on mass m1. The total weight downwards, if you take m1 also into account and m2, sorry, the total forces which are acting on m2, the total weight downwards will be m1 plus m2g, and accordingly the friction force would be equal to mu times m1 plus m2 into g. And since this body is moving forward, initially we have given this velocity, this body has to fall down after moving certain distance, that is distance L on m2. So body m1 is moving in forward direction with respect to m2. So body m1 will experience the force, frictional force in this direction, which will be mu upon 2 m1g, because here the coefficient is mu upon 2, and the bigger body will experience the force because of the smaller body, which will be in this direction, which will be mu m1g upon 2. Now see what all forces are acting on the bigger body. The bigger body, the horizontal forces are mu m1 plus m2 into g, and another is in this direction. So we can take the acceleration, of the bigger body, that is m2, along negative x-axis. Let it be ax be its acceleration in this direction. So force, sum of all forces is mass into acceleration. Use this formula. So mass of this body, you take only mass of this body, because we have taken all the forces in free body diagram. Now don't add this mass on this. I am only concerned about the forces which are acting on this body, so I take this mass. So it is m2ax in this direction I am taking is equal to, I am taking ax positive in this direction. So m2ax is equal to mu times m1 plus m2 into g minus mu m1g upon 2. So here you get mu m2g plus mu m1g upon 2, or we can write as mu g m2 plus m1 upon 2 is m2ax. So ax is equal to mu g 1 plus m1 upon twice m2. Now you have to take into account this acceleration of the bigger body while dealing with the smaller body. Now I draw the diagram again. Now this is moving with acceleration ax. So this frame is moving with acceleration ax. So a smaller body, which I have taken as moving on the bigger body, will experience a pseudo force. Please recall, I am taking motion of the smaller body in the frame of the bigger body, which is m2. Since the frame itself is moving, this body which is taken in this frame, this is m2, it will experience m1ax. The pseudo force is always in the opposite direction of the acceleration, and it is the multiple of the acceleration and mass of that body on which the pseudo force is acting. Don't multiply by m2. Pseudo force is acting on this body, so the mass has to be taken of this body only. And what are the other forces we had seen on the smaller body? The other force which was there on the smaller body was the frictional force acting in this direction. Here we had seen, just see, here we had seen is mu upon 2 m1g is the frictional force acting in this direction. So what are since we are taking the motion of the smaller body in this direction in the frame of the bigger body, so let me take its acceleration as a dash, positive in this direction. So m1 a dash, that is mass into acceleration, is sum of all the forces which are m1 ax, that is in the direction of a dash, minus mu upon 2 m1g. Now place the value of ax. Ax was mu g 1 plus m1 upon twice m2. So m1 a dash is equal to m1 mu g plus m1 square upon twice m2 mu g minus mu m1g upon 2. So you get here mu m1 g upon 2 plus m1 square mu g upon twice m2, or you can take mu m1g as common upon 2, you get 1 plus m1 upon m2 and m1 a dash was here, so a dash value will be mu g upon 2 m2 plus m1 upon m2. Now this is the acceleration of the smaller body, which is the relative acceleration. This is not the absolute acceleration. Smaller body is accelerating in the frame of the bigger body and covering distance L before it falls. This is that point at which it falls. So what is the time taken? The initial velocity, that is the relative velocity, was 0. So we can use this equation, s is equal to ut plus half at square. This is 0 and s is L. So L is equal to half, and a here is the acceleration in this frame because we are solving the problem in the bigger frame. So a is this value, ar dash, which we had called mu g upon 2 m2 plus m1 upon m2 into t square. So t square is equal to 4l m2 upon mu g m1 plus m2 is equal to, now you can write t is equal to under root of 4 m2l upon mu g into m1 plus m2. This is the value. In the book, M2 is given as capital M and M1 as small m. You can place that value and you will get the answer.